Assalamualaikum everyone. Today our group will be presenting for CHM256 in the topic of application of filtration in pharmaceutical industries. Our group member firstly is me, Nawara Hana binti Nazamuddin. Secondly is Sarah Emily Farisha binti Muhammad Farid. Thirdly is Nurfani Najia binti Rabu. And the fourth one is Aminah Najiha binti Zulkarnain. The last one is Siti Nadia Safia binti Syekh Ibrahim. Introduction to filtration. Filtration is used to separate an insoluble solid from a pure liquid or a solution. Filtration usually involves a circle or a filter paper folded to make cone and placed into a filter funnel. The filtrate is the liquid which passes through the filter paper, and the residue is the solid left on the filter paper. Filtration is typically an imperfect process. Some fluid remains on the feed side of the filter or embedded in the filter media, and some small solid particulates find their way through the filter. As a chemistry and engineering technique, there is always some lost product, whether it's the liquid or solid being collected. Filtration is categorized as a gravimetric analysis, in which a method in analytical chemistry to determine the quantity of an analyte based on the mass of a solid. There is 5 types of filtration. The first type of filtration is gravity filtration. This is commonly used in laboratories for separating solids from liquid. Gravity filtration is the simplest and most common use of filtration. It releases the force of gravity to pull the liquid or gas through a filter medium. The filter medium can be cloth, paper, or a bed of granular material. The second one is pressure filtration. Pressure filtration involves applying pressure to force the liquid or gas through a filter medium. This method is commonly used in industrial application where a higher filtration rate is required. Pressure filtration can be achieved using various devices such as filter press, filter cartridge, or membrane filters. The third one is vacuum filtration. Vacuum filtration is a type of pressure filtration where a vacuum pump is used to create a pressure differential across the filter medium. This method is commonly used when a higher filtration rate is required and the liquid or gas needs to be pulled through the filter medium. The vacuum filtration is often used in laboratories and industries for separating solids from liquid. For the fourth one is centrifugal filtration. Centrifugal filtration utilizes centrifugal force to separate solids from liquid or gases. The mixture is introduced into a rotating drum or a cone-shaped vessel where the centrifugal force pushes the heavier solids towards the wall, allowing the liquid or gas to pass through the filter medium. Centrifugal filtration is commonly used in industries such as wastewater treatment and oil refining. For the last one is membrane filtration. Membrane filtration is a specialized type of filtration that uses a membrane as a filter medium. The membrane has microscopic pores that allows only certain size of particle to pass through effectively. Membrane filtration is commonly used in industries such as wastewater treatment, pharmaceutical, and food processing. For the purpose of filtration, the main purpose of filtration is to separate solids from liquid or gases using a filter medium that allows the fluid to pass through but not the solid. For the most basic component for filtration is a filter medium, a fluid with suspended solids, a driving force such as pressure to cause fluid to flow. Lastly is a mechanical device, the filter, that holds the filter medium, contains the fluid, and permits the application of force. For examples of filtration, the first example is water purification methods to remove impurities from water. Depending on the final water usage, different filters are used to eliminate contaminants from the water. Portable water for home usage. The second one is HEPA filters, which is high efficiency particulate air filters, are frequently used for air purification to eliminate harmful allergens, bacteria, and pollutants. For the third one is tea and coffee filters. The fourth one is automatic filters such as air filter, cabin filter, fuel filter, and oil filter. This filter is used to increase the vehicle longevity.
Now, let's discuss the next topic, application of filtration, experiment of synthesis of the paracetamol. First, the theory application of filtration in the experiment synthesis of paracetamol. Filtration is a mechanical or physical operation used of separation of solid from liquid or gases by passing the mixture through a filter medium that retains the solid particles while allowing the fluid to pass through. In chemical synthesis, filtration is essential for purifying the final product by removing unwanted impurities and byproducts, thus ensuring the desired purity and quality of the synthesized compound. The synthesis of paracetamol acetaminophen involves the acetylation of para-aminophenol with acetic anhydride. The reaction yields paracetamol as a solid product and acetic acid as a byproduct. Filtration is employed to separate the solid paracetamol from the liquid reaction mixture, facilitating the isolation and purification of desired product. The chemical reaction for the synthesis of paracetamol can be represented as follows. In this reaction, para-aminophenol react with acetic anhydride. Paracetamol is formed as the main product. Acetic acid is produced as a byproduct. Then the objective of the experiment is to synthesize paracetamol acetaminophen from para-aminophenol using acetic anhydride and to purifying the product through recrystallization. The process involves forming paracetamol crystal and isolating them by filtration. After that, apparatus. First, weighing paper. Second, analytic balance. Third, 250 ml beaker. Fourth, glass rod. Fifth, hot plate. 6, measuring cylinder. 7, ice bath. 8, butcher funnel. 9, filter paper. 10, vacuum source. And lastly, drying oven. Next, the chemicals. Firstly, para-aminophenol. Secondly, acetic anhydride. Third, distilled water. And last but not least, ethanol.
Here are the introduction for this experiment. Paracetamol chemical structure includes a hydroxyl group and an amide group connected to a benzene ring. Its systematic name is N,4-hydroxyphenyl acetamide. The synthesis of paracetamol entails acetylating p-aminophenol with acetic anhydride. This process showcases a significant change in converting an amine to an amide. It is essential to comprehend the production of paracetamol as it has significance in both medicine and education, demonstrating basic organic reaction and methods. This produce will emphasize the hands-on elements of synthesizing, purifying, and identifying chemicals, leading to a thorough grasp of the entire process from starting materials to the end product. Next is the procedure. First, weigh out 5 grams of 4-aminophenol using a weighing paper and transfer the sample to a 250 ml beaker. Add 25 until 50 ml of hot distilled water and stir the mixture with a glass rod to dissolve the sample. In a separate beaker, measure out a slightly excess amount of acetic anhydride, around 7 until 8 ml. Slowly add the acetic anhydride to the 4-aminophenol solution while stirring continuously. Maintain the reaction mixture at room temperature and allow it to react for about 30 minutes. The reaction is exothermic and will produce paracetamol and acetic acid. Cool the reaction mixture in an ice bath. As the mixture cools, paracetamol crystal will start to form. Once the temperature has reached 0, add a small amount of cool distilled water to facilitate the crystallization process. Set up a puncher funnel with filter paper and connect it to a vacuum source. Pour the reaction mixture into the puncher funnel to separate the paracetamol crystal from the liquid. Wash the crystal with a small amount of cool distilled water to remove any remaining impurities. Dissolve the crude paracetamol crystal in minimal amount of hot ethanol. Once dissolved, allow the solution to cool at room temperature and then place it in an ice bath to recrystallize pure paracetamol. Filter the purified paracetamol crystal using the buncher funnel and wash with cool ethanol. Allow the purified paracetamol crystal to air dry or using drying oven at low temperature to remove any remaining solvent. Wet the filter paper plus the paracetamol and record the mass. Here are the results of our experiment. The mass of sample we used is 3.4623 gram. The total mass of filter paper plus paracetamol is 2.144 gram. The mass of filter paper is 1.024 gram and the mass of paracetamol is 1.12 gram.
For the conclusion of the experiment, this experiment successfully synthesis paracetamol by acetylating para-aminophenol with acetic anhydride. It consisted of several steps, including dissolving a substance, undergoing a reaction, forming precipitates, and most importantly, isolating products through the filtration process. With the use of vacuum filtering and a buncher funnel, we successfully collected the crude of paracetamol. In addition, the filtration procedure was necessary to produce a purer product, especially when crystallization was done immediately. In conclusion, the experiment show how paracetamol is synthesized and emphasizes how important filtration is to isolating and purifying the finished product. The synthesis process was more efficient and effective overall as a result of the filtration techniques' successful execution.
Okay, so these are the precaution steps for filtration in the pharmaceutical industry. Filtration in the pharmaceutical industry is a critical process that ensures the purity and quality of pharmaceutical product. It involves the removal of unwanted particles, microorganisms, and other contaminants from liquid and gases. To ensure the effectiveness and safety of the filtration process, several precautionary steps need to be taken. The first one is wear protective garments, splash protection, eye protection, and respirator as required. Implement certain quality control measures to monitor the filtration process and end product. Sterilize filters before use, especially for sterile filtration processes. Common methods include autoclaving, steam sterilization, or gamma irradiation. And you have to always check chemical and thermal compatibility of housing material, O-ring, gasket, and media with the fluid being filtered. Consult a liquid compatibility guide or ask a local dealer. Pharmaceutical industry uses liquid filtration in several different aspects for different purposes. It is employed in several key areas throughout the industry. By utilizing liquid filtration techniques in these critical areas, the pharmaceutical industry can maintain product quality, improve process efficiency, and meet regulatory requirements. The first contribution is obtaining zero water, production of active pharmaceutical ingredient, bioburden reduction, clarification and pre-filtration, and the last one is sterile filtration of finished product. So filtration plays an indispensable role in the pharmaceutical industry, ensuring the safety, efficiency, and quality of pharmaceutical products by removing contaminants, concentration concentrating active ingredients, and facilitating the recovery of solvents and catalysts. Filtration process contribute significantly to the overall efficiency and environmental sustainability of pharmaceutical manufacturing.